Last time we talked about center of mass motion and rotational motion of a rigid body around that center of mass. We talked about how these rotational motions are related to their linear analogs. For instance, distance is proportional to the angle in radians. Velocity is similar to angular velocity, and acceleration is similar to angular acceleration. Just like for linear motion, which had linear kinematic equations, we have rotational kinematic equations that you can use to relate the angle, the angular velocity, and the angular acceleration. But remember that kinematics is only a description. The equations just describe how things move, but they don't explain why things move. In order to discuss the mechanism of why things move, we need to think about how forces affect things and cause not only linear motion but also rotational motion. So forces that cause rotational motion are called torques. This is not the same thing as torquing. This is torques. I think that probably they are related in name. So just to be specific, when you have a linear force, you know that the sum of the forces equals ma, and we know that when the total acceleration is 0, then we know that the total forces acting on that body sum to 0. The same thing with rotational forces. We can say that sum of the torques is equal to mass times the angular acceleration, m alpha, and that implies similarly that when the total angular accelerations are 0, then the total torques are 0. In order for there to be a static equilibrium, i.e. no acceleration of any kind, both of these conditions are required. So you should not have any translational motion in the linear case, nor any rotational motion. But what is torque? Torque is the turning effect due to a force, and it shows up all over, and you're going to see it again in 132 when you're talking about electromagnetism. If you want to think about it, think about how a wrench works when you're trying to use to turn a screw, or even how a door works. So you apply a force to the door. If it has a hinge on one side, that part cannot move, and so you torque the door, causing a rotation of the door relative to the axis through the point of that rotation. To put it more specifically, if you apply a force to a center of mass, such as the object on the left, then you get the object to move. But if you apply a force to the edge of the object and the center of mass may be fixed or another position may be fixed, then what you get is a rotational motion. How do we find torque? So we can define torque as equal to the distance from the rotational point r times the perpendicular force that is applied. And by force perpendicular, we mean it's perpendicular to r. So if you're looking down here, let's just say that this is a door and it has a rotation point on the left indicated by the black dot, then the distance between where the force is applied and the rotational force is the distance r. In this case, r is horizontal. If we apply a force downward on the door, it's perpendicular to the direction of r, and that force gets multiplied by r, and that gives us the torque. What are the units of torque? So r is a distance, so it's measured in meters, and force is measured in newtons, which is kilogram meter per second squared. Putting that together, we get that the units of torque are meter newtons, and there's no other special name for it. What if the force is not perpendicular? For instance, you're not paying attention as you're trying to go through a door and you approach it from an angle. If that's the case, then we should think about breaking down this force into the perpendicular and parallel components of the force. For the perpendicular component, again, I mean perpendicular to r. That would be a vector pointing downward in this drawing. This is the only part of that force which is going to have any effect on the rotation. The other part of the force, which is parallel to r, will have no effect on the rotation. And you can think about that. That makes sense. If you tried to slide a door to sideways, but it was attached to a hinge, you're not going to be able to actually move it.